Hi children, now we are coming to another very important mathematics topic. It is differential calculus. That day we did integral calculus and we have seen it's important in finding the potential due to, due to a point charge or a potential due to a magnet pole. Both of them are similar, so we have seen why we need integral calculus. Now we are coming to differential calculus. Look at this graph. This is x, this is y. This y may be displacement, x may be time. And this is the line which suit the equation y is equal to x. This is the simplest we get. Y is equal to x. This will be 45 degrees. Now, what will be y by x? Y by x will be AB by BC, the slope of this. That means the displacement with respect to time. That means this is a velocity. Another one also, this will be a velocity, PQ by QR. And both of these are equal, we have seen. So this is a simple case. Now dy dx also you can do. Dy dx and y by x in this case will be same and then there is no difference. And the last result will be y is proportional to x. The more the x, the more the y, and this is the thing. So if y is displacement, x is time, I told you displacement is proportional to time. So displacement is equal to kt and k is d by t, it is velocity. Now, when we plot now velocity on y on the same equation, velocity and time, we will get a constant velocity. And when the velocity is constant, acceleration dB dt. There is no change of velocity with respect to time, so we'll get acceleration to be 0. So this is a simple. Now, we come to another equation, very important one, y is equal to x squared. So y is equal to y and x. When x is 1, y is 1 square. When y is 1 square. When x is 2, y is 4. When x is 3, y will be 9. See, 2, 4, and then when it is 3, y will be 9. See, now, here y by x can no longer be taken same like the first one because it is curving like this, so we need differential at every part, differentiation at every part, so we will get dy dx will be a function of x. So this is a graph when y is equal to x squared. Now, y is equal to x squared. If x is incremented by a very, very small amount dx, y also will increase to y plus dy. So y plus dy will be x plus dx whole thing square. And here comes those mathematics you have done, algebra, you have done a plus b whole thing square in class 7, 8. So x squared plus twice x dx plus dx squared. Now dx is very, very small, say 0.00001. Now dx squared will be 0.00000. It will be much, much smaller, so dx squared can be taken to be 0. So at last we have y plus dy x squared plus twice x dx. Dx squared is no more, we have omitted it, too small. So y plus dy is x squared plus twice x dx. Now y is x squared, so x squared and x squared left hand side cancel with right hand side. Dy dx is twice x. So this is the first problem that you will get in differential calculus. Dy dx is twice x when y is equal to x squared. Now, we can also show that if y is x cubed, then dy dx will be 3x squared. Here also that algebra a plus b whole thing cube is equal to a cube plus b cube plus 3ab into a plus b. You come there, and with the same thing that dx cube is omitted, you will get dy dx is 3x squared. And general one, if y is equal to xn, dy dx is nx n minus 1. See here, 3x 3 minus 1, here nx n minus 1, general one. Now, we come to a very important use of differential calculus as well as integral. Now, when I want to find the area of this square, we used to say length into breadth. That is okay. But we need a proof. How do you know that this length into breadth? So here what we do, because it is a rectangle, we have to find the JCM and all this. So let us say that this is 1 centimeter, 2 centimeter, and 9 centimeter. This is 1, 2, 3, 4. So I created a square. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So 9 into 4, there will be 36 square in this, 36 units square. So that is the main principle of finding the square, not L into B. L into B comes from this very root of the mathematics. So now we will come to finding the area of a triangle. This is a triangle. The equation of this is y is equal to x. So this line is one line, this is one line, and this. Now, how to find the area of this without doing this? You cannot use AC, then split the rectangle half of that. No, that is not allowed. You have to find it by integral calculus and differential. So I select here dx. When I select here dx, at this point, this is y, this is dx. So what is the area of this? F, E, G, DH, it will be this into y. So this is the whole area. But now this is so small, I omitted this. So what we have now? We have y into dx. See? We will get here, where is it? We'll get here y into dx. But what is y? Y is ax. See, if a is 1, then y is x. But here this is general. Y is ax. So y, where is this? This is ax dx. This is the area. Ax is y into dx. This is the area. Now, the total area of this triangle will be summation of the small element here, just like this, from here to this. So that we are doing it by integration from 0 to x. So 0 to x, ax dx is equal to a, take it outside, x dx will be a is constant, x dx you will come to standard integral x squared by 2. This one we'll do later on also. So the area of the triangle is ax squared by 2, which in geometry it is half base into altitude. So this is all the what we get here, half base into altitude. Now, in differential calculus is very important in the study of capacitor charging. So the capacitor charging, so this is the one, this is a capacitor, this is a 6 volt or B volt, then I on the switch. When I on the switch, the charge will increase at the beginning because this was empty. The charge will flow with with a great speed. It will go up, and then when the charge is full, the capacitor is getting full and full with charge, then the Q will slowly come down, and here the Q will remain, the charge will remain constant, the capacitor is fully charged. So now when we discharge it, so this is the circuit. After charging this, I bring OA now quickly to OB. OA charging OB. Then the discharge will be this. The discharge, you see, this is this one. The discharge is this one. You just put a mirror. If you put a mirror here, see, this is up and this is down. And you'll finally come to 0. So this one, the graph is known to be exponential. Exponential rise, exponential decay. So this you will get it in capacitor. You will also get it in inductance. In inductance, when you on the battery, the current will rise like this, and then when you off it, and then here, that didt, L didt of inductance will be very important. And here also, capacitance, we will be doing it in the next class. And this is the charging, and this is the charging, and these are known as exponential curve. Exponential curve. And only differential calculus and integral calculus can deal with this type of problem. So we'll meet in the next lecture. So we will come to this. Oh, one thing also, exponential, the earthquake measurement, the unit also is in Richter scale. All these are exponential. See, 6 Richter scale. Earthquake in one place is 6 Richter scale. It is not twice 3 Richter. It is much more. See, 3 and 6 is double, but not that. 6 Richter scale damage is far, far greater than double the 3 Richter scale. So these are all exponential calculation. Thank you.